And we're live. Hello, everybody. Welcome to the first online meetup of the Dutch Angular group. I'm Jeffrey. I'm here together with my co-host, Bjorn. Say hello.
Hello, my name is Bjorn, and we will be using Slido today for our interaction. So if during this presentation or any other presentations you have any questions you'd like to ask the presenter, head over to slido.com and use the hashtag Dutch-Angular-group. You should not have to make a account or anything like that to ask questions. So go ahead and join us here. And Jeffrey, I'm sure we want to introduce our first speaker soon, don't you?
Yeah, sure. So Martina's here. She will give us an amazing talk and tell us something about yourself.
Hello. I'm Martina. I will introduce myself a little bit more inside my slides. I'm based in Germany. I'm really pleased to be here and talk at the second Dutch meetup. So I'm really looking forward to all your questions and everything you have to say to me. I'm really looking forward. I'm really glad to be here.
Great to have you here. And we have an amazing other speaker. That's Siddharth.
Hi, hello everyone. My name is Siddharth Ajmera, and I'm a full stack JavaScript developer based out in Sydney, Australia. And this is my first time giving a talk here at the Dutch meetup as well. I'm a Google developer expert for Angular and web technologies, and I'm really looking forward to presenting you a few things about Ivy today.
Great, thank you.
Awesome, Jeffrey. Just before we get started, for the people watching later, if you're watching this later after the live stream, unfortunately the interaction is closed. But do not forget to follow us on Twitter if you want to be part of these events in the future. Might as well hit that subscribe button just to make sure you never miss an event. Jeffrey, what do we want to do now?
Well, it's all up to Martina probably then.
Yeah, I guess.
Good. So let me start sharing my screen. And you should be able to see it.
It's coming. There it is.
Yes.
The floor is yours.
Awesome. Thank you so much for the nice introduction and for having me here again. What I'm going to talk about today, I will talk about today about our most awesome favorite rendering engine, Angular Ivy, the rise of a new compiler. Why do we need a new compiler? Yes, that's a good question. Maybe you know that Angular basically always had a bad reputation of having like so much huge bundle sizes and a really bad initial loading time. So an aspect I'd like to cover today is, of course, the whole performance. This is a metric that was taken from Lighthouse. It's a browser extension. You might know it. If not, you should know it. Immediately after the two talks, go to your browser and install it because it's an amazing tool for all the measurements, not only about performance, but also like for the whole security and best practices. It gives you advices and might help you to even improve your website as well. So one metric, of course, is the performance. Like we have the first contentful pane, the first meaningful pane, and speed index. And of course, talking about these kind of matrices, the most important thing is, of course, the initial bundle size. So the initial loading time is the thing that leads then in the end to, of course, bad performance, a bad first meaningful pane and a first contentful pane, and hence a long time when the user actually is able to interact with you, right? So the time to interact. But not only that, Ivy, and what I'm going to show you today as well, is how Ivy actually not only increase and optimize your initial loading time, but also the developing, the build time. Because in the past, really, it took so long for the production builds and so on. And that is something as well they optimized and increased with Ivy. To get to know what is actually the costliest resources on a web page, like why the hell is this bundle size actually so big? We need to answer this question. What is actually the costliest resource on the web page? What actually leads to the point that our bundle size is so big? You might think HTML, yes, but we have a single page application, right? So there is no such like 50 HTML files. It's also not styles, of course. As you all might know, it's JavaScript. And this is the thing why Ivy takes place and why we needed a new compiler, because the compiler is responsible for compiling TypeScript, and everything what we develop with Angular into JavaScript. That's why Ivy needed to be there, and Ivy jumps here to the rescue. First of all, let me introduce myself again, so I will extend it a little bit. I'm also a Google developer expert in Angular and web technologies. I'm a woman tech maker ambassador, so I'm traveling around the world, being on conferences, talking about great stuff and things I love, mentoring, and this is for my free time. And as a paid job, I'm a trainer and consultant, and giving workshops and developing in Angular and everything what you can imagine, actually. I'm also a core team member of ngGirls. If you haven't heard of this already, you should immediately go after these two talks to the ngGirls page and take a look into that. The next we have planned is actually already in 2 days. It will be on Saturday in Australia with Siddharth together and 2 other awesome persons. We are organizing together the very first ngGirls event in Australia. And we already have around like 80 persons in total over there. It's going to be amazing, and it will be. Apart from that, and because I have way too much free time, I'm also co-organizer of the German Angular conference, the NGDE, which should have taken place this year in August, but unfortunately we needed to postpone it to next year for obvious reasons. And I'm also supporting and helping NG Rome, which also will get postponed to next year spring. Apart from that, I want to share my biggest passion with you, because you will see a lot of GIFs inside my presentation on it. It's basketball. I played already for like, I guess, 24 years now. I played basketball. And the GIF is from a movie called Space Jam. If you haven't heard of it, it's a movie with the famous basketball player Michael Jordan, and together with the Looney Tunes characters. And maybe you also remember the title song of this movie, which was I Believe I Can Fly. I'm not starting to sing because I can't at all. I should not. But I want to promise you that with Ivy, you definitely can fly. So let's take a step back and take a look into why we do actually need a compiler. What are the tasks of a compiler? And maybe if you are familiar with C and C++ and other compiler languages, you might know we are in web technologies, right? In web technologies, we don't need a compiler. So what is the deal here? Why is it called a compiler? Yes, it's not like that we have C or C++ compiled to machine language. We actually compile this whole Angular declarative code to JavaScript code. So there is a compiler, it's called the Angular NGC, the Angular compiler. You can just run it from your terminal, and we will do this later. And this actually compiles your whole Angular application into pure JavaScript code. JavaScript code that has the standard, ECMAScript standard, that you define by yourself inside the tsconfig JSON. Remember, inside the tsconfig JSON, you have all the compiler options and all the flags you can set for having this compiled, and as well the target version of it. So here is exactly the place where Ivy now jumps in and replaces the Vue engine, which was the previous Angular compiler. Furthermore, a compiler is, of course, responsible for the whole scoping, like when we have Angular modules, these ng models that we lazy load, also that everything stays exactly in the right scope if we're declaring pipes and components and so on. And of course, furthermore, the whole evaluation by the TypeScript compiler of the property chains, the variables, the types, checking interfaces, and everything, what makes TypeScript so awesome and why we use TypeScript, of course, in Angular. Since we have cleared up the basics, I want to show you the rise of a new compiler, a compiler that is called Ivy. We will get a couple of benefits out of this compiler. We got promised it will be smaller, it will be faster and easier. I mean, bam, bring it on. That is so amazing. Smaller, faster, easier. Okay, let's see. So I will pick out every single point and I will show you why. So here's the deal about my talk. I will show you why Ivy brings now all the benefits, and Siddharth later, which is really an awesome talk, will answer you the question, okay, and so what? So what can I do now with Ivy? And I can promise you it's amazing, and you should stay for this talk as well. So I like to share a small diagram with you that was actually shared by Stephen Fluin in one of his blog articles, where he got some measurements regarding the size improvements for Ivy compared from version 9 Ivy versus version 8 View Engine. So here we can see that it brings up to 40% in large applications of a size improvement, especially for small and large apps. It might not be that much for medium apps, but I will show you later as well why this might be the case, that for medium apps, the bundle size doesn't improve that much. We will see that. Okay, so I was like, okay, I don't trust statistics, right? So let's do it on my own. Let's compile it. So all I did, I had Angular version 9. I created a new application, and I had version 9 enabled Ivy, which is by default, of course, enabled since Angular 9. And I disabled Ivy, and I run both, like that, once with View Engine, once with Ivy. And then I got this this result. To say, of course, this is neither compressed nor optimized or something. It's just like running the plain compiler. So it's not minified or some other optimizations, just like that. And the result was that with version 9.1.2, I got a size of 1.3 megabyte of the View Engine and 14 kilobyte by Ivy. And I was like, hold my beer, bring it on. What is going on? What the hell is actually going on inside these files? Why is it so much smaller? And let's see, should we? So I have here a small application. It's just, all I did was ngNew, and I just removed a little bit of the boilerplate code here. So I just removed this whole side of the hero tool and everything what is usually there, and just replace it with a small hello world with a interpolation over here. As well, as I said, this is version 9 right now. We can see it here, the 9.1.2. And so I had to compile it with the View Engine, with the compiler before, I needed to go to the tisconfig.json and set a flag Angular compiler options to false. Like there's a flag enable Ivy false. So we have version 9 compiled with the View Engine. And just to show you, again, here's, by the way, the target version of the JavaScript that will be compiled. So yeah, let's compile it, right? So all we need to do inside the terminal, we will run GC. It's sometimes from time to time, it takes a long time, of course. And I always do this joke like, yeah, I try to do jokes, but we Germans don't have humor, so I better not do that. So, but it already was really fast. So it created here a dist folder. And what we see here, I mean, what should we expect in here? The whole JavaScript code, right? The whole application compiled to JavaScript. So let's see what was actually going here. So when we shortly take a look here on the side, we have one component. We have just one app component, .html, the CSS file, of course the test file, but the normal TS file. Okay, so let's see what is actually compiled here. If you're going here to source, and then we see everything is in JavaScript, and let's open this little folder where our component should be compiled into, right? Okay, looks interesting. So what is going on here? So we have like a lot of component files here. There's something like app component.js. Okay, what is this? Okay, this seems like to be the compiled version of our app component.ts. Okay, so far so good. We also have a couple of JSON files. I just will explain what's there inside. There's basically like the whole dependencies, like the references between the files, some symbolic links, that we have a reference between all these files and the dependencies of the component. But what I want to show you as well is actually the ngFactory file. And let me shortly, yes. So when we see shortly, I split it that you can see it even better, and then we'll format it. So when we see here this whole HTML on the left side, we see that this seems to be the file which actually is responsible for rendering this HTML. So we have some function called on a I1. Okay, this is the core library, right? So this theta vid, which is the view definition, is a function or is something that gets something inside. And I mean, I know it already because I'm studying this for already a long time. But the first look at it is really like, what the hell is going on here? And then we have something like theta eld, which is the element definition. Okay, element definition. So something like on the first index, we have a div. Okay, we have a div. And usually here would then be displayed some properties that are inside this div tag and a lot of nulls, like whatever. I don't know what's going on here. Here's the text definition, I see. So here's the text definition, which is then the hello, what we see over here. Oops, sorry. I just clicked out. So which text actually, to be honest, to me, this whole thing is like really going to debug. Let's take a look how actually Ivy is compiling that, right? And if it maybe looks way better. So keep in mind, we have like a lot of files here, like a lot. Of course, we have also compiled. We have a lot of component files. Okay, so let me shortly delete this folder that it will be created again. And of course, what we also need to do is enabling Ivy again. So by deleting this enable Ivy flag to false. So let's delete this and save it. And let's just compile it again. Actually, I'm even a funny joke, to be really honest, but okay, I remember I need to start another thing. Okay, let's check this later. But I already prepared. I need to first run it and compile it completely too, and then I can ngC, but it's fine. What I want to show you is this folder. I prepared it already before because sometimes it does that. When I didn't prepare the run compilation before, but yes, you can ask me later about that. So it would have worked completely perfectly. You would see another disk folder, which then now be this Ivy folder here. And what we would see then now, so I pre-compiled it already to make sure if something gets wrong, because it's live demo. Live demos always there's something wrong with live demos. The IDE out of the sudden decides, no, I will not work for you because it's a live demo, apparently. So that's why I pre-compiled it already before. And here's the folder as well, the disk folder, but with Ivy compiled. And we have the app folder. And here we see we have 3 files. Actually, 1 file, right? Because this is the file of the app module. This is the file of the test file. And this is the component file. Now, let's take a look into that. So basically, what we see here, I just thought that I changed it already, but anyways. So what we will see here is actually that they have static properties. And these static properties got introduced in Ivy and in Angular 9. So every single component, every single building block, like the services, the modules, has this static properties, which now gets a function that's called define component. And this I0 is as well from the core framework. Maybe let me shortly replace this, that it's a little bit easier to see, that it's more readable. So these are the functions from the core framework. And in the core framework, there's a define component function. And then you see that, yeah, there's something just shortly missing, just because usually there is something like if. I just played already around with it, that's why it's right now wrong, but let's shortly just how it should actually look like. There is a 1, because it's needed for my explanation. So it will most probably look like that. Master plan. So, so basically, there is this function, a template function, which now has the whole definition of how the template is actually rendered. So here inside, we actually getting a so-called rendering phase and let's say a context. The context is something which is related to everything that we define inside the component class. Like for example, the title over here, which is of course like our interpolation title that will be interpolated later in later stages. So we have two stages, rendering phases over here. The first one is called the init phase. So as soon as ngOnInit is called, we call the framework. So this component calls directly the framework and creates an element on the index 0 with the div. Then it creates a text node, then it closes the element. In the second rendering phase, which is the update rendering phase, we get the element and then we interpolate it. And that's what I meant with the context. We get actually all the whole information about our variables that are inside the component. And then we have, of course, like the whole metadata, which is actually inside the decorator, inside the component. So that said, this whole one single file has everything that needs to that it needs to know for actually rendering the whole component. And this is much more easier to read, right? I mean, like element start, element end. This is way easier to read. So okay, let me shortly summarize this point. Like with the View engine, we got actually out of 3 files, we got 4 files. We had this component file, which is the equivalent of the TS file. We have the ngFactory file, which is actually the file that is responsible for rendering the HTML. And we have 2 JSON files, which just doing the references between the ngFactory and the component file and handling the whole dependencies. In comparison to Ivy, we actually do have just 1 single file. And this is really amazing, right? So this might be the reason why actually the bundle size with Ivy decreased so much. But I can tell you, of course, it decreased already, but there's actually another reason why the bundle size with Ivy is so much smaller. Because, and now you have to prepare, hold on something. Maybe you should sit down, because the View engine is not tree shakeable. What means tree shakeable? Tree shakeable means that you have that code elimination, that you actually that you remove functions that are not called. Like for example, there's a function called say hello, and you never call this function in your whole time, then it should not be in the final bundle, right? So that basically means to be tree shakeable. But that said, when View engine is not tree shakeable, inside my final bundle, there will be functions that I'm not using in my Angular application. And yes, you're right. But why is that? Let's take a look how shortly View engine is actually compiling and rendering the HTML. So if you have here HTML, and what will be rendered inside the ngFactory file is something that's called view definition, an array of instructions. So we have view definition, and it takes this whole array of instructions like an element and a text definition and maybe a pipe definition, whatever, what kind of building blocks you might like. And here, as you can see, it's not like really that we're calling function, it's just an array of instructions, right? So there's nothing to be called. So when are actually these things created? Inside the core framework, like inside the compiled version of the core framework of Angular, we have a function. This function is called createViewNodes. And this takes the view definition, as you can see here. The code snippet is a little bit simplified. If you run ngC and you get into your compiled version of JavaScript and you search for createViewNodes, you will get the whole thing. So you can take a look into that. So this createViewNodes takes actually a view definition, and for each node, so for each entry in this array, it iterates over it. And if this node is something like an element, then and just then it calls the function createElement. So if it's like from a type text, then and just then calls the function create text, and so for the create pipe instance, and so on and so forth. And I just simplified it as here a lot, as you can see. But we have in real life, in the real life out there, we have actually like over 150 cases that then just calls the function. And that said, in our Angular application that we compiled right now, we actually just had create element and create text, right? And all the other cases will be still shipped inside the final bundle, because during compile time, we can't recognize right now here when the functions are going to be called, because it's just the switch cases are based on runtime. So during compile time, we can't know that, right? And this is the reason View Engine is not tree shakeable. Okay, how about Ivy then? Yes, as you might remember, the whole component actually calls the functions directly. So remember, we had this core framework, and inside this template creation function, we actually called element start, element end, and text, and so on. So all the Ivy instructions that are just exported functions inside the framework are immediately called directly by the component, and not like over through switch cases and so on. So here we can definitely define which instructions are used and which not, because it will be directly called, right? There's a direct reference to it. So all the unused code, for example, the pipe, will be tree shaked out. And this is exactly the reason why Ivy has so much smaller bundle when it comes to small and large apps, but not medium-sized apps. Because medium-sized apps might, in the end, eventually call all these functions, these template creation functions. So it can't really be tree shaked out either ways in Ivy as well. And that's why it doesn't take that much effect on medium-sized apps. I mean, this is pretty nice. This is pretty awesome. Okay, we understood why we have smaller bundle sizes. Let's dig. It is actually the main point. So the main point of my talk was about the smaller bundle sizes. Let's shortly look what is regarding the faster compilation. And if you saw Kara's talk on ngConf this year, she said that together with Basil, they reached a 40% improvement of faster compilation. 40. This is like so amazing. I mean, 40 is almost 50, and 50 is half. This is so incredible. So why is that? Of course, we have a single file compilation. So we just have one single file to be compiled. Of course, that makes it a lot of easier because we don't have all the references between back and forth of these files. But the actual reason for that is the locality principle. The component has all information for being compiled. Yes, it needs all the information for being compiled, right? Because otherwise it can't be compiled, apparently. Yeah, true, but it does know the component compiled by the View engine, unfortunately, does know even a lot more of stuff. If we focus, for example, here on a compiled version of the component with a structural directive, the ngIf, you see that after this ngIf, there's something in the array brackets as well, something that's called view container ref and template ref. And maybe some of you know, but these two services are actually dependencies on ngIf and not of my component. So let's say let's just imagine it doesn't, I know, but let's just imagine the constructor of ngIf does change like many times. All components which are using this directive, which are most probably quite a lot, will definitely need to recompile again and again and again, and the whole application needs to be recompiled. And this is really something like, this is really like, because we use a lot of different kind of directives. We don't have just ngIf, we have our own directives. So the component does know all what it needs, but it does even know more, right? So how it is with Ivy? We just have something like, okay, somewhere in the framework, there's an Ivy instruction how an ngIf is eventually going to be rendered, because it's written down inside a static property for ng directives. So all I can say here, okay, there is inside the common library, there is the class ngIf, and inside this ngIf we have ngIf, we have a static property which has then the function, like the definition of this directive. So this will be completely separated, compiled, than the actual component. So whenever a service, a dependency of the ngIf changed, or of our own directive, whatever, not the component needs to be compiled, just this little snippet needs to be compiled. And this is so amazing. So they introduced a concept of separation of dependency compilation. So every dependency, everything regarding this clear, defined API, well-defined, well-formed API, we can compile everything separately. This is really amazing. So we have a separation compilation of dependency. There's no global compilation anymore. But actually what this leads to, and this is so amazing, is that the mod that we just imagine, we can actually ship modules inside our Angular application already ahead of time compiled. Because the compilation of them is already like finished. We don't need to recompile them. Everyone who uses Angular material knows that sometimes it's like, it needs to be all the modules, everything needs to be compiled again and again. And Angular material is sometimes really even buggy from time to time. And it's sometimes really a little bit annoying. But if this is already pre-compiled and shipped maybe through a package JSON to us, it's like, it's nice. And even Bugs Bunny thinks it's nice. So so it has to be it has to be nice. So this is really like as well a future step and a future thing that will definitely will come with Ivy. Before I sum up, just some last words, and Sid will dig deeper into this as well, because it's already a little bit the future. Why is it easier to debug with Ivy? So in Angular 9, they introduced this whole separation of compilation and a cleaner API. As you might already imagine, as I said in the beginning, it might be really a mess to debug through this whole the framework, which is compiled with the Vue engine, like setting breakpoints over there, or like, because you have to immediately dig into the core framework code, which didn't look really nice with all the switch cases, and this could lead a lot of like work, and so debugging wasn't really quite nice back then in Angular. And of course, we don't have to jump from one file to another file to another file. Everything is just one single file. That said, stack traces most probably look something like this, like our awesome, famous expression change after it has been checked error. It's always said that we Germans put so many subjects together and then we create new words. But this is also like, it's one of my favorites ever. I always thought of like creating stickers out of it and putting it everywhere. But yeah, so if you get an error like that, you can see how it looked before and how it looked after now, like with Ivy now enabled. You see immediately that the function where it occurs is inside this template creation function of this app component. And there you start, and there you can dig deep into that. Okay, what is actually going on? As well, and Sid will actually show you this in a demo. There was a small ng object introduced, like a small debug object, which you will get inside your browser developer tools, and you can actually get the context of a component and then change variables inside the component. With the function apply changes, you can actually trigger a change detection cycle, and so on and so forth. So it's amazing. It's really, really amazing. I won't say too much about it because Siddharth will show you all the magic you can do with it. Last but not least, the backwards compatibility. Because, of course, like the Angular team can't just bring out a new compiler and say, here's a new compiler, I don't care. You have to take a look after yourself how you deal with it. I mean, it's the heart, right? It's the core thing of the whole Angular application. So the first thing they really worked on, and they did a great job, was of course providing something that is called a compatibility compiler, ngCC. And this compatibility compiler actually iterates through your whole node modules. And if there is something in the older version, or like compiled with Vue engine, and the Ivy compiler, the normal usual ngTSC compiler, Ivy compiler, can't really compile this one. The ngCC takes care of it and provides something that is called TypeScript definition file. So if you might compile something with Ivy, and then maybe you can take a look into your node modules folder, you will see something _Ivy _, and exactly there inside are the TypeScript definition files actually placed and compiled. So, and with this TypeScript definition files, the Ivy compiler can work then and can, of course, compile this as well. This is really amazing. Yes, it's true that there are, of course, still some open issues and still some with really old libraries. Or I get often asked this question, can I compile AngularJS code, like the really first version of Angular, like 1.x as well with Ivy and a hybrid? Many persons have hybrids, like mixed AngularJS and Angular code, and can I compile it with that as well? There are still some things that needs to be done. I mean, like the first thing you need to be done is just migrating AngularJS to Angular. That would be a good start, of course, and I advise that to everyone. But of course, please, if you have some issue, ping me or ping Siddharth or anyone who's like really familiar and deep into Ivy, or file an issue on GitHub on the Angular core team. They take a look into that. But you can also reach out, as I said, to me and Sid, and we can maybe bring that concern further to the Angular team as well. As I said, it's default in version 9. Ivy is already there. You should enable it, and you should use version 9, which has the default enabling. But when you know already when you have already some issues and you can't get rid of these issues, you can also disable it, but you should not, of course. But it's possible. But I guess in the version 10, which will most probably be released in May or June, so we're really excited about it. It might be still possible, but in the near future, Vue Engine will not be available anymore. That said, let me shortly summarize the whole talk. We learned that Ivy reduces the bundle size significantly, like really a lot. And this was, of course, the main thing, one of the main reasons Ivy was promised and everyone focused on Ivy. I can tell that the whole team focused on Ivy. Regarding the bundle size, because it was a big deal back then in Angular, of course. It only recompiles what changes due to the fact that we have a separated recompilation of all the dependencies, which is so amazing. And we have a great backwards compatibility with the new ngCC compiler. Before I completely finish up, I want to mention something as well, of course. So everyone focuses right now on the bundle size, like, yes, you promised me the bundle size will decrease so much and will be so much smaller, but I don't see it in my application. And I always would like to refer on Minko's tweet back then, that he said, yes, but if you do the basic things wrong, your bundle size will not decrease. The basic things like lazy loading or using the latest version of our XJS, where all the operators will be actually tree-shaked out as well. So if you don't do the basic things right, even Ivy is not a hero. Ivy is not like something that you can see as, okay, every miseries in my whole life are solved. Of course, you do the basic things right, and there are great talks out there of how you can increase the performance, and then Ivy will help you as well to make it even more smaller. But what I actually want to say is that Ivy shouldn't be seen as the bundle size reducer, but Ivy should be seen as an enabler. And this is exactly the last sentence where Siddharth will now start over with, because Ivy is an enabler which enables a completely new way of things you can develop your Angular application. And this is exactly what will be shown in the next talk, as I said. And I promise you, the future of Ivy is really amazing and bright. So thank you again for having me. You can ping me anytime on Twitter or send me an email. I do also have a website where you'll find a couple of more informations about about me, contact details. If you have any kind of question, I would like to answer them now, or then maybe via email or Twitter. So thank you so much for having me.
Well, talk about questions. Martina, can we get a virtual applause first for that presentation? I'm not sure everybody can hear that, but yeah, let's imagine we had a full crowd going for this. Thank you so much,
standing
Martina.
ovation.
Woo! Yeah. Woo! Woo! Anyway, thank you so much. The people that were on the Slido, the link is in the chat somewhere. I think if you still have questions, we'll keep it going. There are a couple of questions, unfortunately all anonymous, so we can't use the names. So no 2 minutes of fame for you. Sorry. So. Martina, yeah, take your time. If you need to cough or take a sip of water, go for it.
No, I'm good. I'm fine.
So one of the questions here by an anonymous person asked, like, all this sounds like great build improvement, but how does Ivy help us, the developers? Do you have a short and snappy answer for that?
Yes, watch Sid's talk.
Exactly.
Because as I said, I just showed why, and Sid will answer the question, so what?
Yeah, exactly. Okay. All right. Awesome. So to the anonymous person that asked that question, don't go anywhere. This question will be answered very soon for you. A new question coming in just now, so it's working. I'll have to pick and choose. This is by Sen Alexandru, who we saw from Romania. Thank you for the complete and technical presentation. That's for you, Martina. Why did the Angular team decide to create Ivy as a new engine and not upgrade the existing compiler? Do you have an idea about that?
You ever heard the sentence of like, sometimes it's better to delete everything and rewrite from scratch than refactoring, because the whole architecture, the whole concept, basically everything of the compiler, it would not be possible to just refactor Vue engine. And then it's just because sometimes decisions are based on sometimes written code are based on decisions which are just not up to date anymore and not aligned with the possibilities you have right now. And so the decision was based on then, and like we have Vue engine from Angular version 2 till 8 now, and we have a lot of more possibilities. You can rethink your decisions, and I always love as well to just maybe throw everything away and rewrite from scratch, because you're much more experienced right now. You have much more greater ideas. And I think it was the best idea they could have actually ever made, to just say, okay, we rewrite everything, because it's the basic whole concept, the whole architecture, the concept, everything just changed completely.
All right. Well, I hope that answers the question there to the person who asked that. Oh, that's a Sen, of course. Yeah, so that's a good one. Another anonymous question. Do you think Ivy is stable now, Martina?
Yes. I mean, yeah. Yes, it is. It is stable. And the thing is, like, I mean, like you find things in every kind of software that might not work out for you, because maybe there is some issue. So when we talk about, I have always issues regarding stability, because when is the software really stable? I mean, you will always find something. There's like when I open Microsoft Teams, or when I open Alexa, or when I open whatever, there's always something, it crashed or something like that. I mean, stable is always really not an absolute. This is a really absolute sentence. But if you want to have an absolute answer, then I say yes, it is.
Very good. I think we'll do well. We can do two more, maybe two smaller ones.
Yeah.
When do you runtime debug your Angular apps in your experience? By anonymous.
Oh, sorry. Can you repeat? You were short.
Yeah, I was wondering. You were sitting very, very still there. So no. So when do you, in your experience, when do you runtime debug your Angular applications?
When I get an error like expression has been changed after view has been checked. I don't know how many times I get this.
It's always the same one. Yeah.
I don't care. So many times I get this, and because basically really to figure out how many change detection cycles, what is triggering again the next change detection cycle, and things like that, like to really figure out when my variable gets a new value and from where this value is actually coming. I mean, to have a short answer, when there is an error. As soon as there's an error, I debug my application, right?
Yeah.
So yes.
The infamous expression changed after it has been checked error you won't be able to get that error in prod though. But yeah,
Yeah. Yes. Yes. Yes.
uh,
Yes.
whenever you get an error, you do need to. Uh,
Yes.
Final question, and it's actually two, but they're quite similar or basically on the same wavelength, I think. So I'm gonna do them as one. There might be another one. Oh, no, we'll see. So there's a question about the expectations for the new June release, and also in that same regard, I think, what do you think can still be improved on Ivy? Like, are there any like actual concrete points that you think Ivy is still lacking or needs more focus on, or that can still make a big leap in? Any like things come to mind for you?
Regarding expectations, I would not like to tell a lot about that because even the Angular team itself had a lot of issues in the past regarding setting expectations, because then as soon as they needed longer time, they're even so sensitive already right now of saying even a release date, and like really so Igor always says we just not maybe really saying a release date, because as soon as we're not able to fulfill this release date, everyone is attacking them. So I want to keep my just I can promise that they focused now again on Ivy, like all the features how you can develop your Angular applications better with Ivy, like things that Sid will show as well. They worked on this definitely as well. Things that can be improved in Ivy, yes, and they're still doing that regarding this compatibility compiler, because sometimes it's still like what the error I had. It was an issue actually regarding that. That there's still like when you have to recompile your template, you need to do sometimes you need to surf it before. Things like that. So regarding the template creation, I think they still need to improve that a little bit. Things about that, but apart from that, they already did like the whole team was working on Ivy. Like I can promise, feels like for 4 years. So right now the focus is right now on all the things that Ivy brings to your way of developing Angular applications.
Awesome. Well, Martina, I guess I'm speaking for everybody right here, right now. Thank you so much for the talk. All the questions that were left are basically about these same expectations. So thank you so much for exceeding our expectations and giving a fantastic remote presentation. For you watching right now live or watching later at home, we'll be back after a 3-minute short break. Don't forget to get on the Slido if you have questions during the next presentation. We will be right back. Don't go anywhere. Siddharth's going to blow your minds.
Whoop, whoop.
So you thought it was only a one me today. Well, guess what? It's two for Thursday. We have a second presentation coming up right now. Welcome back, Jeffrey, my fellow co-host, Jeffrey.
Hey, welcome everybody.
Yeah. So hope nobody's gone yet. Siddharth's just getting ready for his part of the presentation. There he is, casual, late at night for our Australian friend. I'll quickly take this opportunity to, once again, I've been doing it a lot, but I mean, more questions is more interactivity, right? So to get over to the Slido, if you're not already, if you have any questions during the presentation, we will be having a short Q&A after. So head over to slido.com and use the hashtag Dutch-Angular-group to ask your questions. Of course, for the people watching it after the live presentation, this opportunity has passed for you. Hope to see you next time. Make sure to follow us on the YouTube channel or on Twitter to be updated of any events. Jeffrey.
Yeah, thank you. So, Siddharth, the floor is yours. We're amazingly excited about this talk because this is the thing that Martina said that will be awesome.
Okay, that sets a really high expectation.
No pressure there.
All right. I'll just quickly start the recording on my local machine and I'll start sharing the screen.
Yeah.
Yep. Okay.
Yeah, I can see it. Here it is.
Perfect. All right. So let's get started. I'm going to talk about the present and the future of Angular with Ivy. So things that you can do right now and things that you will be able to do soon in the near future with Ivy. A lot of people out there would tell you that Ivy is an enabler, right? And you might have heard this exact same expression from a lot of people out there in the community that are really working quite a lot with Angular. So my intent is to justify this particular expression, and through the talk that I'm doing, we will be able to do that, hopefully. Now, Martina has talked about a few things. When Ivy was designed, the Angular team had a few design goals in mind, and they sort of distributed that into three major categories: optimizability, incrementality, and flexibility. Now, optimizability and incrementality is something that Martina has already talked about. So I'll then go ahead and talk about flexibility. So we'll talk about how we can get simple and easier things with Ivy, and a lot of other things that we can have with Ivy. So a little bit about myself first. Hello everyone, whoever is watching from anywhere around the world. My name is Siddharth Ajmera and I'm a full stack JavaScript developer, currently based out in Sydney, Australia. I'm a Google developer expert for Angular and web technologies, and I've written a few articles for indepth.dev. I'm also a Udemy instructor for 2 courses on Angular and Firebase. And just in case you might want to reach out to me, I'm available almost anywhere on the web with this handle right here. So just in case you might want to reach out, come say hi. All right, so I've divided this talk into 2 sections. In the first section, we are going to talk about the present things, the things that we can do right now with Ivy. And I'll be demonstrating this thing with a few examples so that you can see things in action. And then I'll also talk about the things that you will be able to do in the near future with Ivy. So let's start with the first one, which is small and meaningful stack traces. So in order to understand this, I have around 2 examples. Both of them are on Stack Blitz because I love Stack Blitz for some reason. And I guess it's a tool to be loved. So yeah, I'll just open those 2 examples up. And here in the example, we have tried to somehow reproduce the infamous expression changed after it has been checked error, as Martina mentioned. So this first example, I'm running Angular 9, but Ivy is disabled right now. So if I just open this up, all right, yeah. So IV is disabled right now because that's why the enable IV button is not checked. So this is like the view engine code that you see right now. I will also open this up in a new tab so that we can see the whole error as such properly. And this is the second example wherein we have the exact same code in place, but here I'm using IV, and that's why enable IV is toggled to true. So, um, and you will also be able to determine that with this particular emoji. I am a big fan of emojis. That's how I express myself quite a lot these days. So let's start with the view engine and go to the console and see this error that we are getting that says expression changed after it has been checked. Right. Now, what exactly do I do about this? How exactly do I actually figure out what was wrong with the expression or what was wrong with the code? So if I just click on this, it takes me somewhere to this point wherein the error actually happened, but then there's no way out as such for me to find that until and unless I maybe place a breakpoint here. And then if I reload this, I'll probably get a stack trace out here, and then I'll have to scroll through that whole stack trace in order to actually determine the point of error, which is a very difficult process, to be honest. So I probably might not try that in the interest of time, but I'll do try to do the exact same thing with IV, because as soon as I click on this error, which happens on this particular line, it takes me directly to the place wherein that error occurred, and it takes me to this particular line. Uh, I'll also quickly shortly go through the code as to how exactly we are getting that error. So I have this app component wherein I have this hello component as a child component, and to that I'm passing the text property that I have on the app component right here. I'll just split the editor. Right. So this is the text property that I'm passing to the hello component as an input property name. And here is the child component that is accepting that name as an input property, but it is also trying to change the text property on the parent inside the ng on init. And that's why we are getting that error, right? So uh, with this, I will be actually able to navigate myself to the place the wherein that error happened, right? And this gives me a pretty good understanding as compared to this, that is the view engine code. The breakpoint broke here, but here's the stack trace. I'll probably have to click on this anonymous function to go to the app component HTML, and then this takes me to app component HTML, but then I don't really get a sense of what exactly was this error all about. And then I'll have to probably check the app components ng factory file. But then, as Martina has already mentioned, the ng factory file is really hard to reason about, right? Because it has a lot of nulls and magic numbers going around here and there. So this doesn't really give me a great sense of idea as to what the error was all about. Now, one way to fix that expression change after it has been checked error was to actually call the ng after to call the detect changes method that would run change detection when the second time this property was changed, right? And so as soon as I do that and go back to the console, let's also try to reload the application. It might take some time, but I can totally see let's maybe try to open this in a new incognito window, because I did face the issue while loading the app. Come on.
Always the
Right.
demo effect, right?
Yeah, we cannot really do anything about this. But yeah, as you can see now, the console is clear. So I have gotten rid of the error, and that's great. So again, the stack traces are small and meaningful. And once you click on the line that was throwing this error, it takes you directly to the actual point wherein that error happened. And that takes you to the actual template instructions that threw that error, which is a good thing, right? That's first. Second is ahead of time compilation by default. So with IV, things are now so fast and so performant, then we can enable ahead of time compilation by default in our Angular applications. And that has a few advantages on its own. Let's have one look at one such advantage. So in here, I have the app component TypeScript class, and then there's this HTML. Let me just close that. Okay. Now I have the app component HTML and the app component TypeScript class open side by side. And as you can clearly see, the function that I'm trying to call on the click handler of this event, on the click event handler, is the load component lazy lily. Now I might have typed that while I was in a hurry, but this was an error, right? And because of this error, this application should not have compiled successfully. And that would have been the case if ahead of time compilation was there by default. But I get the error only after I click on this button. So I get a runtime error right here. And as you can see, it says that this function, this particular thing is not a function that exists on my TypeScript class. Now, the reason I'm getting this error is because enable IV is set to false. And that's why I'm still running the view engine code. As soon as I enable IV by checking this checkbox, it will now start to use IV for compilation and rendering. And with that in place, it will also use ahead of time compilation by default. And because of that, ideally, now the app itself should not compile. So let's see. And as you can see, as soon as it stopped the compilation, we get an error right here before even rendering the actual HTML and before even me clicking on that button, right? So I do get an error saying that this is not a method. And this is actually pretty good when it comes to developing applications, because you might not want to be the person who is actually debugging these runtime errors after the production release went live, right? So let's just be that good developer that we are and fix this by renaming the typo that we had. And I should now see the UI getting rendered properly. So ahead of time compilation by default. And this is one of those helpful things that we get, which also enhances our developer experience, and we get errors right before building or deploying. Next, we have a feature wherein we can now load components lazily. Before Angular 9, you could load modules in Angular lazily, but with Angular 9, you can now even load components lazily. And so let's have that as an example. Right. So I'll show this example on a local setup of Angular CLI, because StackBlitz does some performance optimizations behind the scenes, and it doesn't really perform really good while demoing lazy loading. So for that, I have an app module. I'll just open that up. So app.module.ts. And that's the module wherein I have declared two components, app component and timer component at the moment. All right. So let's open the app component TypeScript class. And let's also open the app component HTML. And I'll again split screens. Let me just also okay, let me just move this down a bit. All right. So I have this app component TypeScript class, and then there is a button on the UI. Clicking on that button calls the load dashboard lazily method, right? So what does that method do? It's an async method that calls the dynamic import statement to the dashboard component. And the dynamic import statement is going to give me a JavaScript module, right? So I'll just have to destructure the dashboard component from there. And then what I do is I call the resolve component factory method that I have that I call upon the component factory resolver that I've injected as a dependency. And that gives me the factory. And then on that factory, I pass that factory to the create component method on the view container ref. The view container ref is something that I have used via the view child, from where I'm getting this host for lazy component. So I read this host for lazy component as a view child, and I just read the view container ref from there. And this is the same old plain logic wherein we can use this in order to load components lazily or load components dynamically in Angular, right? So let me just go to the application that I have hosted here, and I'll just click on the network tab, clear everything off, and clear everything off from the console as well. Now, as soon as I click on this button, you will see that the dashboard component gets downloaded on demand only once I click on this button. So that dashboard component is not really bundled as a part of the main bundle. It is bundled separately and gets downloaded to the client only once it's requested, as you can see right here, right? So this was something that was not really possible before Angular 9, but it's now possible with Angular 9. And it's great. All right, so here's the dashboard component. And again, if I open the app module TypeScript class, you won't see the dashboard component here in the declarations array, right? So this was a dynamically loaded component. Great. So that's that. The next thing is the ng object that we can use for debugging purposes that Martina talked about. And this also is available only in the development mode. So let's have a look at that. So here I am in the developer tools on my console, and I type ng and press enter. And that gives me access to a few of these APIs that I can use for debugging. So one thing that I will need here to debug is a component or an element at least that I can use, right? So if I go to the elements tab and there is this element selector, if I click on this element selector and maybe select a particular HTML element, let's say this H1 that says maybe someday you'll start believing it, and I then go back to the console, what it does is it gets stored in a global variable named $0. So if I type in $0 and press enter, you will see that this H1 was stored in this $0 variable. Nice. Now let me try to do the exact same thing with this one. So if I select that, it now stores this H1 tag in the $0. So if I press $0, that's the second one, which is this H1 tag, right? But where did the first H1 tag go? It now goes to the $1 global variable. And you can have multiple of these $0, $1, $2, and the list goes on and on and on, right? How exactly is that useful? Well, you can actually select the whole component as well, right? So let's just say that I select the app dashboard component via the element selector, and then I go back here, and if I press $0 back again, I should now see, let me just clear everything. Yeah, so I should now see the app dashboard component. Now, how do I use that? Well, there is a get component method on this ng object that you can use, and this expects something. What does it expect? It expects an element, right? Now, we already have this element, something referencing this element in this $0 property. So I can just use that $0, and it now should ideally give me a component. So let's store that component. I'll call that dashboard in this constant, and let's press enter. Now, if I type in dashboard and press enter, I should now see this dashboard component, and I can also see that this dashboard component has a show property on it, right? So let's say that there was a case wherein I wanted to assign a few values to this show property, and then I wanted to check how my component behaves on the UI while it's running, right? So at runtime, how would I do that? Well, I can just try doing that. So I'll do something like dashboard dot show, and then I replace the original value with something new, and hopefully as soon as I press enter, this component should get updated, right? So let's try doing that. I press enter, and maybe I'll wait for a few seconds, but nothing really happens, right? But I now remember that Martina in her talk told that there is an apply changes method as well available on this ng object, and that is responsible for change detection, right? So I have changed a property, but I have not performed change detection yet. So I'll have to perform that change detection manually, and so in order to do that, I'll just call apply changes method and then pass it this dashboard component. So dashboard, yep. Now as soon as I press enter, hopefully the GIF should change, and it did, right? That's amazing, because now at runtime, even though in the dev mode, I can now make some changes to the properties and change these values, and then also see how my component behaves while I'm doing that. And that's a pretty useful utility when it comes to that. There is also a link to an article that I have added on this slide. So please do feel free to check that out and read through that. There are a lot of other useful tips that you'll get from that article. Great. Now I've talked about a few things that you can do right now with Angular 9 and Ivy. Let's now talk about the future. And the future is really exciting if I tell you that. So we'll have a look at a few examples in which we will see how Ivy brings a lot of good developer experience as well as a lot of features with Angular's newer versions. But before that, one most important thing that I'd like to say is a lot of people out there are probably not really interested in building a full-fledged application with Angular. They might just be interested in just rendering a component, right? So just rendering a component with a lot of buy-in regarding a lot of these other modules that Angular needs isn't really something that is ideal, right? Because why would I really have to pay the cost of the rest of the framework if I'm not using it in the first place? With Ivy, you don't really have to, right? But then there are a few things that you will have to do on your own, right? Because Angular modules, you can think of Angular modules as linchpins for a complete Angular application. Angular modules define quite a lot of things like change detection using zones and dependency injection and how directives and pipes and things of that sort are used, right? But if you don't have Angular modules in place, these are a few things that you will have to do on your own. So let's first have a look at a way to render components without Angular modules from scratch. So I have created a stack blitz for this one. I'll just open that up. And I hope the stream is not lagging and everything is in place.
No, you're good.
Oh, perfect. Great. So here is a very simple example wherein I have just 4 files. Now, this is something that you might ideally not see in an Angular application, because an Angular application is a very big application and it contains a lot of other files apart from the ones that you might see here. But this one just has 4 files. There's just index.html file wherein I have just one host tag, which is not even a built-in HTML tag. There is this index.typescript class wherein TypeScript file wherein I have some code written, and I'll go through that. There is this styles.css file, and then there are a few dependencies that are also defined in our package.json file. So at the moment, I just have Angular core installed, and then there are also these other 3 dependencies like rxjs, tslib, and zone.js. Now, as soon as I install Angular core, it will automatically get added because Angular core somehow depends on them. But we won't use them, right? We will just use Angular core, and we will build and render a component that looks something like this. This is an Angular component, by the way, and this is written completely in IV instructions. So what exactly are these IV instructions that I'm talking about? So I'll open up the index.ts file. There are imports to a few theta and a lot of these APIs. These APIs are really private at the moment, and that's why they are prefixed with theta and theta. But to get the general idea, these are a few IV instructions that are responsible for rendering this HTML that you see on the right hand side of the screen. Now, uh, Martina has already mentioned a few of these things like the theta factory function and the theta CMP. I'll just quickly go through that. Uh, I have my IV component TypeScript class with a property named name and a method named toggle name. And inside toggle name, what I'm doing is I'm just changing the name and toggling it between Sid and IV. That's it. Now, there is a theta factory function. This theta factory function is going to be responsible for generating the instance of the IV component, which is my TypeScript class. And then there is this theta CMP static field as well, which actually defines my whole component. So it has a lot of other information apart from the template function. But let's zoom into the template function. What exactly does that do? Well, the template function is, again, as Martina has already explained, is going to be responsible for rendering our component in 2 phases. One would be the initialization phase and one would be the change detection phase. So if the value of this render flag that gets passed as an argument to the template function, if the value is 1, then the initial rendering phase would go, and if it is 2, then the change detection phase would go. So this is like the very simple IV instructions that we have used in order to render this component. There's this element start at 0th index, and then that element is of type h1, and then there is this text node, and so on and so forth. There's also a button here somewhere, and I'm binding to the click event on that button. And as soon as that click is happening, there is a listener that is listening for that click event and then calling the toggle name method that I have present inside the toggle name method right here. Perfect. And how exactly is this getting rendered? Well, it's getting rendered with this just one beautiful line. This render component or theta render component is IV instruction. You just give it the component with all that definition, all the factory function, and all these static fields that it might need in order to generate itself. And you also define a host wherein it should actually get rendered. So this host right here is this tag that I'm using in the index.html. If I just rename this to IV, I might get an error and I might not see anything. And then I'll have to just replace this host with IV, right? And this is a really cool feature that I'll be showing you how exactly is this useful. But yeah, now I do see the component in place, right? And then there is also this toggle name method that toggles the name between Sid and Ivy. So as soon as I click on the change name method, ideally this text right here which says Sid should change to Ivy. So let's try doing that. Let's click on the change name button. Now I'm clicking on the change name button quite a few times, but I don't really see anything getting changed over here, right? And at this moment, I'll again reiterate to that point wherein I said that Angular modules are linchpins in an Angular application. And so Angular modules are responsible for doing quite a lot of things. And defining the zone.js and how change detection works is one of those things. But I'm not really using a module. And so this application doesn't really know how to detect changes, right? So how exactly will this detect the change? Well, the good thing is we also have something called a mark dirty IV instruction right inside Angular core. How exactly is that going to help? Well, this is just going to mark this component as dirty so that whenever the next change detection cycle runs, it updates or synchronizes that model and view, right? So as soon as I call this, and this needs to be called with this instance, you just save that. And as soon as I do that, and now let's click on the change name. Okay, now it changes these values. So if I click on change name, it toggles between IV and SID. Great. So change detection is working even without using Zone.js, and I have been able to now render an Angular application even without using Angular modules. That's a great start. But would you really type all these things in order to render a component? I wouldn't, because like I'm not doing it right away, right on this talk as well, right? Because this is really complex code, and like typing this by hand is not really going to be a very good user experience or a developer experience, so to speak. So what exactly do we do? Well, Martina just told in her talk that this is the sort of code that actually gets generated by the Angular compiler, right? The Angular compiler takes your Angular component and then it generates or adds these static fields to that particular component, right? So the basic idea here would be that if I pass this component via the compiler, then I should be able to also have these static fields on it, right? So let's try doing that. Let's try using the Angular compiler and try to build or try to uh, run this application with the compiler. So I've created a second stack blitz here wherein I have the exact same things. I have this exact same tag right here in the index.html, which is host. And then there is this index.ts. Uh, this has a few changes, but then apart from that, the rest of the things are same. One thing that I've added here is the Angular compiler, because now we need it, right? How exactly are we going to use the compiler though? So uh, the initial things remain the same. So we do need a selector, which is IV, which is the exact, it doesn't really matter what the host here is or what the selector here is, as long as we have the exact same host in this host property for the render component. But instead of now typing in all those IV instructions, I'm just calling the compile component IV instruction and passing it the IV component right here. And then this is the metadata, which is actually the metadata that we pass to the add component decorator, right? So it has a selector and it has template and all these other things of sorts. And with that in place, it should now still work as expected. I just added this particular compile component IV instruction. The compile component IV instruction was again taken from Angular core, but we do need to import the Angular compiler as well so that it could be compiled. But yeah, with that in place, now I'm not really writing any of that IV instructions manually, and this compile component IV instruction is doing all of those things for me. And that's great. And with that in place, everything is working as expected as well. And again, here, since Angular modules are not in place, I will have to manually run the change detection by calling this mark dirty. But there is again an issue with this, right? I mean, you wouldn't really do make calls to the compile component or the render component IV instructions again and again manually. There can be cases wherein you might miss something. Even this theta, if you miss at the moment, it's going to break, right? So you get the idea, right? That if there is any small mistake in the code, it might not work, right? So how exactly do we deal with this? Well, the good thing about these decorators is that you can actually create your own decorator, and that's exactly what Uri Sheked once did. He created a decorator, a custom one, that could call the compile component IV instruction on a component, right? So instead of now decorating our component with the with the component IV instruction, I just made a small change to his decorator, and instead of calling just the compile component IV instruction, we are also calling the render component IV instruction right inside the decorator. And so this gives us the exact same experience as an Angular component would do. And this is the exact same way we are used to writing an Angular component, right? We just define a TypeScript class. We decorate that TypeScript class with a decorator, and then inside that decorator we pass some metadata. That's how we are used to using the component, right? So that's exactly what this is doing. Here I'm just again calling the compile and render component decorator. This is a custom decorator that um, I took some inspiration from Uri Sheked and then built. And so what this does is it again just first calls the compile component IV instruction, then calls the render component IV instruction. And the good thing about this is I'm already getting the host from the metadata selector, right? So this is the exact same selector which we have right here. And this host is the exact same thing that we have inside the index.html. And so I should be able to render things, and even change detection would work with this case. So with the help of just this custom decorator, you will be able to do things like that and write components the way you are used to without even using Angular modules. Great. The third thing is dynamically loading a lazy component with IV's render component. Now, in the previous version of Angular 9, what we just saw was that we had to first inject the component factory resolver and then call resolve component factory on that. Just pass this component to that. And then we had to also call this create component method on the view container ref and so on and so forth. So there was a lot of noise in this particular code, which has now been fixed with this render component IV instruction. The render component IV instruction is just one line thing. You just have to call the render component IV instruction, pass it the component, and pass it the host, and you're sorted. You don't really have to do anything else. And that's exactly what we are going to do next. So uh, let me just comment the first example out wherein we loaded the dashboard component lazily. And let's now load this long named component, whatever the name is, loaded via render component. Yeah, I'm really bad with naming things, so just bear with me. So if I open the app module, you won't see that module being added to the declarations array. So that module is definitely not going to be a part of the main bundle. Now, on the click of this button, I've done the exact same thing that I did for this load dashboard lazily method, which I called for the first button, the previous one. Uh, this is a similar async method wherein I'm just calling a dynamic import statement to load the render component loaded via render component, and then I'm going to destructure it out from the JavaScript module that gets generated, and then I'm simply going to call the render component IV instruction, which is something that I've imported from Angular core, right? And then I'm going to pass it the host. This host is the exact same thing that I have right here, this one, right? So I save this and let's go back to the application. Let's see if this works. So I'll go to network tab, clear everything from there. I'll go to console, clear everything from there, and let's try to click on the button. And the component was loaded, right? So again, I just did this one thing. No more calls to the component factory resolver dot resolve component factory and the view container refs dot create component method, right? No calls to all those things. Everything is now going to be handled by the render component IV instruction. Great. One specific thing about this host property is you just need to pass it something that you already have on the template, right? So at the moment, I have this very long tag name, and I might make some mistake while actually typing it, even though the Angular's language services do give me IntelliSense and code help and all these things of sorts. But still, just bear with me for example's sake, I guess. uh, Let me just rename this to anything, and then I can basically use anything here as a host as well. So let me just type in anything here, save this, and let's check if this works. So I'll clear everything from the network, clear everything from console, and if I click on this, I do see that this this JavaScript module for this loaded via render component was called, but then nothing was actually rendering here. What happened? So host node with selector not found. Okay. Oh, all right. So I didn't really save the app component HTML, and that's why probably I was getting that error. I should hopefully not get it anymore. So I'll go back to the network tab, clear everything. If I click on this button, I should see that call made and this component being loaded. Great. All right. So this works. But there's one thing that I wanted to talk about, that if I go to the loaded component via this long component names TypeScript class, I see there is this selector, and the good thing about this is now I don't really have to consider the selector as anything, right? I can just use anything here, and as long as the host property is set to this exact same thing that we have on the template, it's all going to work as expected. Great. But what if I had a dependency injected on this component, let's say some data service, and I wanted to call this data service inside my ng on init lifecycle hook? What would happen in that case? Now, you do have to consider that this is a component that was rendered lazily and dynamically, right? So how exactly is this going to understand or know what injector is all about, what dependency injection is all about, and how exactly is it going to inject the data service as a dependency? There's no way out, right? So if I try to now run the code after saving this, after uncommenting this code wherein I'm injecting the data service as a dependency and calling this, let's click on the button. Nothing really happens. I don't see the component getting loaded. And I also see an error on the console saying that inject must be called from an injection context. Whenever I see something related to inject, I can totally tell that it has an error or it has an issue with it has an issue with dependency injection, right? So uh, now it's pretty clear that the dynamically loaded component doesn't really have an injector in place, and that's why it can't inject any dependency, right? The good thing about this render component is that this second configuration object also takes in an injector, right? So I can pass in an injector to it, and uh, I can also inject the injector as a dependency. So I can just pass that injector to this dynamically loaded component as well. And as soon as I do that, let's clear everything. I'll click on this and I see the component getting loaded. And then on the console, I don't see anything on the console. I did have this data service and a call to that in place. Oh, now I do see. I think probably it had it took some time to load the application, but yeah, I do see this object that was fetched from this JSON placeholder API, and I see that on the console, right? All right, great. So now we also see how dependency injection can work in the dynamically loaded lazy component. It's time to finally have a look at one last demo of tonight, and that would be higher order components in Angular, right? Higher order components are actually really cool, and why do we need them is something that you might be able to know if you have a discussion with React developers about it, right? I mean, React does it, right? So it must be cool. Anyways, jokes apart, uh, so for this particular demo, I'm just going to leverage a demo that was done by Eliran. Um, and this demo is all about a timer component. So there is this timer component that is rendered conditionally with an ngIf. It has an alive property here, which is a boolean, which we actually have on our app component right here. So initially it's true, but I can switch or toggle this alive property by these two buttons. That's destroy and revive. Destroy is going to set alive to false, which would then unmount this component from the DOM, and alive will set this to true, which would again reinstantiate this component and set that component to the DOM or render it to the DOM, right? And if I go and open the timer component, so timer component TypeScript class, it's a very simple component wherein I have a subscription. So I've just used the timer RxJS creator function to create a timer of 1000 milliseconds, and then I pipe through that to log whatever it emits to the console. But then I also subscribe to the count and then set the counter property on this component, and which is exactly the same thing that I'm using via the string interpolation syntax on the template. And in the ng on destroy, I'm just being a lazy developer right here, and I'm not really unsubscribing through this subscription, right? There are a lot of different techniques that you can use to unsubscribe from subscriptions so that you can uh, avoid memory leaks. But I'm just being a bit lazy here, and I am not really caring about memory leaks, right? So I do see this thing getting logged to the console, and this is getting logged via the tap operator that I have in the pipe right here. So if I click on destroy, ideally this component should be unmounted from the DOM. And so that's exactly what you'll see on this line, wherein you won't see the timer again, but you will still see this timer running on the console, which is getting error from this tap operator, right? So there is a memory leak. Let me just try clicking on the destroy button. So I don't really see the timer here, but I do see these numbers getting logged again and again to the console. So how exactly do I deal with this? This is just one component right here wherein I would have to actually manually unsubscribe. But then there might be a lot of other components, like if you have a very big reactive application that might have, let's say, hundreds of these components where you are actually where you actually have to subscribe to an observable instead of using the async pipe in the template, then you'll have to write that same logic again and again about 100 times, right? That doesn't really make sense. So there should be some way in order to write some code and then leverage it for all these other 100 components or 99 components. So in order to do that, we can create a higher order component. A higher order something would be something that actually returns something by changing that, right? So that would mean that if I say a higher order function, it is a function that returns some function, but it changes that function on the way. So a higher order component in this case would be a component that returns component, but then it changes or makes some changes to that component. So that's exactly a higher order component that Aliran has already written, and I have made a few changes to that, conforming to the Angular 9's theta fac and theta CMP static fields. So what this unsubscriber higher order component does is it gets that component definition. And on that component definition, there would be a theta fac static field, as you already know, that can be considered as the original factory, which I will need in order to generate the component instance. And that's exactly what I'm doing on line number 9. And then I'm replacing this uh, initial factory with a call to the dependency, with a call to this particular method right here. So remember that the theta fac static field is basically like a factory function that returns the component instance. So that's exactly what we are doing inside this function. Now, what exactly is a higher order component? It is a component that returns a component, but by changing it, right? So the change that we are introducing in this component is right inside this theta fac um, static field that we are actually recreating or redefining, right? So we create an instance of the component, and then on this component definition, there is again a theta CMP static field which has on destroy on it. Now, if there is ng on destroy lifecycle hook already defined on it, then I'm just simply going to call it. But then there is also this keys thing, which is a string, array. So the general idea here is that I'm just going to pass in all the observables or all the subscriptions that I might have in my component inside this keys property. And then I can iterate through these keys, and then I can simply call unsubscribe on them, right? And then simply return the component instance. So with that in place, I can just go back to the timer component and call this unsubscriber decorator. And then also pass it this subscription name that I have, which is counter subscription, and save it. And as soon as I do that, let's try reloading the app. So right now the counter is running, right? But as soon as I click on destroy, let's see if the counter also stops. So I'll click destroy now, and the counter has stopped at 15, right? So we have eventually been able to stop that memory leak, right? Which is great. And this is like one of the use cases that was excellently explained by Aliran in his talk that he gave. The link to this talk is mentioned right here, so please do check that out as well. A big shout out to Aliran for this. Great. And now you might think, where exactly from here, right? So I just gave you a lot of examples wherein we are rendering Angular components without Angular modules. Well, this is actually something that a lot of developers out there have in mind, to just render Angular components without Angular modules, Zone.js, RxJS, and all these other uh, baggages that we might need to opt into just in order to use Angular for our components, right? So there is a demo that Minko has proposed. So what he has proposed is this depths property that you can use in order to declare all your declarables, and then with that in place, you don't really need Angular modules at all, right? So this is probably something that you might see in the near future with Angular. And with that being said, thank you so much for listening. And just in case you might have any questions regarding this talk, please do feel free to reach out to me on Twitter at this handle. And yeah, thank you so much.
Can we get yet another virtual applause here for Siddharth? Actually amazing. I need a second to gather my thoughts here, because I am all over the place right now. That was amazing, dude. So many cool examples. A couple of questions coming from the audience. Ed Zago had a question about the lazy loaded component standalone, not belonging to modules and can be used in many modules. Is that, like, I think the question here is, could you reuse lazy loaded components over multiple modules?
Yeah, I think once you actually have downloaded the module, I don't really think you would need to download it again. I'll probably have to check this out, but I mean, that would make sense.
That would be even cooler if it's lazy loaded only once, because it recognizes. Yeah, that would be amazing.
It does.
Oh, Martina adds that it does. So, well, Ed, hope that answers your question, man. Fantastic stuff. I have a maybe a little bit more of a difficult question, because I'm not exactly sure where it happened, and there's a little bit of a delay on the YouTube. So, Sid, you might have to help me out here. There's a question by Michiel about why the tech changes here and not marked dirty. And I think it was between the second and the third stack blitz example you showed, where one of the components where you were doing everything with marked dirty with the theta in front of it, and then switched to the tech changes. And the question here is why the difference?
Did I?
If you can share that on the screen, perhaps.
Yeah, sure. You caught me there.
No, that's all right, man. This is the question part. Now it's all improvised, right? So don't worry about it.
Yeah. You can actually totally use mark dirty here as well. Let's try that out.
So he found the example within a second. So that's
yeah.
Michiel, not a problem there, man. Yeah.
Mm-hmm. You can just use mark dirty here as well, and it should pretty much work as expected.
So, all right, then I'm gonna follow up question. What's the difference in a sentence? Yeah.
I'm not so sure about that. What's the exact difference? I'm not really sure. I'm sorry.
That's okay. We found a thing.
I mean,
sorry, Martina?
Mark dirty is without Zone.js, and detect changes just works with Zone.js.
There we go.
If you have Zone.js enabled, both are working, because mark dirty would work either way. It doesn't matter. So because mark dirty has this theta sign in front, it's still this private part of the private API of Ivy, and this Mark 30 is just without Node.js, and detect changes just with.
Awesome. All right. So Michiel, thanking you for your answer. That's good stuff there.
#PIL.
And thanks, Martina, for the add-on. This is actually proving to be one hell of a session here. So another question by Ed Zago. Mind blown, literally. Well, that's a compliment for you, Sid. How does Ivy stand against Angular elements? It sounds like a full-fledged replacement. I'm thinking he's referring to a lot of these private methods you're showing already. Do you have an answer to that? To how it stands up to Angular elements so far?
So I don't think there is anything against Angular elements in here. It's just more or less like Angular elements would eventually implement things this way.
Yeah, it will just evolve, basically, probably.
Yeah. All right. So I guess in the same line, here's a question. So how close are these APIs to what will be available in versions after 9 or bigger than 9? It seems like these APIs would be good for micro frontends. I guess it's kind of in the same wavelength of how it stands to Angular elements. And that question is by Tame Piper, by the way. Don't want to miss your shout out.
So I don't really have a concrete answer to that, but in order to like just visualize it from the way there is a difference between a few of these APIs, right? Like say for example, if I go to this one, there are a few things that the Angular team doesn't really want you to touch at all if you talk about production ready applications, right? So there is this double theta right in front of a few of these APIs, but there are single thetas that you might have for a few of these APIs, right? So that being said, you can just think of it in a way that the ones with single theta might be available at some point in time. I mean, I don't really know which versions to be specific, but yeah, you can probably think of these as some APIs that you would be able to somehow use in the near future. But apart from that, these double thetas are some things that are eventually going to be always private in nature.
Awesome. All right. I think we'll do 2 more because we've been going for a while and it's very late where you are, Sid. So let's do 2 more if you don't mind, and then we can get to wrapping it up. So Michiel has another question about the unsub higher order component you showed. Would it not be possible to look at the types of the component members and auto unsub those instead of having to give it the keys?
Yeah, you can also do that. And actually Aliran's talk that I have mentioned in this slide on the 5th one actually does it things that way. So he has actually created a helper method that determines whether this object has a key that is of type subscription, and then based on that he is calling unsubscribe on that.
Amazing.
Yeah.
So big shout out to that talk. And that brings me to the final question that I had in mind, because I think a lot of people are interested in your examples and your slides. Will you be sharing these? And this same question goes to you as well, Martina. Where can we find your slides after this presentation? Of course, if you're watching this in the future, they will be in the description.
So I'll be sharing those slides on Twitter.
Yeah, sure.
That's my handle.
Yes.
Awesome. Give yourself a quick shout out, Sid.
Yeah, you can just
handle?
Yeah, that's my Twitter handle. So
yeah, here is mine.
There it is. Yeah.
Martina Kraus 11 and
Ajmera.
Yeah, there we go. Awesome. All right, so that wraps up the questions I had from the audience. And Jeffrey.
Oh wait, can we do a high five? I always wanted to do that. Like this high five, like that.
Well,
Wait,
like no, like
here.
Oh, that.
Yeah, the other way around. Yes, the other way.
Other way, Sid. Other way. Yeah. Yes.
Okay, that's wrapping up actually this show. We just wanted to do one more thing, and that is announcing a bit of our next show. The show will be probably in 2 or 3 weeks, and it will be in the theme of Scully. So we'll have some people over, and I will talk all in depth about Scully. So thank you all again for your talks. It was a really amazing talks and a really good evening. And Sid, thank you for staying up that late.
No worries. Thank you so much for having us.
Thank you so much. Thank you.
Thank you.
Bye-bye, guys.
For you watching,
Bye.
subscribe and see you in the future.
Bye.
Bye-bye.